How can I change my design as fast as I change my mind? With synchronous technology, design reuse doesn't have to mean remodeling. Anyone can change any model, regardless of who created the original, without having to unravel and debug how it was built. The result? Engineering change orders in seconds that would have taken hours. In this gas turbine assembly, we have been asked to make a number of changes to the main shaft. In conventional history-based models, this would require an understanding of the construction approach. Synchronous technology removes the need to understand the way a part was designed. Simply selecting what needs to change and to change it, rotating with simple pick and drag options, making model changes fast and visual. More control over the behavior of the model can be achieved by adding 3D dimensions. Real-time dynamic feedback ensures that we get exactly the change we want while making sure that all the necessary geometry is updating, reducing the time taken to perform the modifications. Many times, more than one component may need changing to ensure design compatibility. Using conventional approaches, we would need to open each component to make modifications. Synchronous technology allows us to make changes in related parts, speeding the design change process. Let's look at a more complex geometric case. Take this complex part with over 1,500 features in a traditional history tree. When an engineer wants to make a change to these 3 ribs, they have to trace how they were created in the original model. After investigating the model, our engineer sees that this feature was generated by sketching a profile. This was done very early in the model development and appears early in the history tree. Selecting the profile allows us to edit the dimensions using the same constraints as originally defined at creation time. But these constraints complicate the edit we now need. The original designer may have had some ideas on what was a likely change, but how could they have predicted that we would want to make this change? To make this simple change, the user has to understand the way the model was constrained. Once they do so, the history is replayed to get the model to update. Notice how long it takes for the model to recompute. With synchronous technology, a user simply selects the geometry they want to edit. The powerful feature recognition understands the functional form of the ribs and selects everything we need by using the geometric recognition capabilities, reducing the need for the user to understand the modeling process. This leaves the engineer in total control over what changes within their design. Let's take a close look at a new technique we call procedural features using a pattern. Notice how a dimension can be used to change either the overall shape or the size of the pattern. Notice while the pattern was created last, it can drive the initial base shape, a first for CAD. A pattern's instance can also be edited. Watch as the entire pattern maintains the requested size. Patterns are procedural features and support parameterized edits, such as instances, but allow direct modification. These features are unique in the industry. Only with synchronous technology will users have this level of flexibility. How do I thrive in a multi-CAD world? With synchronous technology, designers can easily access and edit models created in any CAD system, regardless of the design methodology. Synchronous technology enables even occasional users to edit CAD data from other systems faster than the original system can. In today's global engineering environment, we see data from a variety of sources being used in a single product. How to get the most from this information while speeding the product development process is a major challenge. Using synchronous technology, we can take geometry originated in different CAD systems and copy it into our new design. The shapes can be adjusted in size, shape, and orientation, significantly reducing design time. Using traditional approaches, engineers have to plan for reuse, imagining ahead what will be a useful design element, relying on the creation history, forcing the user to understand about the initial creation, not a realistic situation when a library item was added a year ago. Synchronous technology allows for on-demand reuse strategies, enabling geometry to be quickly shared between parts regardless of the data's origin. In this case, synchronous technology enables you to use powerful engineering tools for simulation-driven design optimization regardless of the origin of the data. Consider this plastic handle. With a design delivered from an external supplier, our in-house team has been tasked with considering some alternatives to increase its strength. The problem is that the supplied model doesn't have any feature history. With traditional approaches, we would be forced to make manual changes to the geometry or to rebuild the ribs with parameters and then remeshing and reanalyzing at each step. Using synchronous technology, our teams simply add the dimensions they want, and automated simulation and optimization can be performed on the target parts of the model without worrying about irrelevant variables. With the ability to add constraints to the model where you need them and when you need them, regardless of the origin of the data, you now increase the value of multi-CAD data in today's global product development marketplace.
This new synchronous technology is indeed a breakthrough. It marks a new era in modeling that allows an engineer the freedom to be an engineer. With an instantaneous modeling experience, this is going to change the way people think about using CAD. It's going to change the way CAD enables them to think about what they want to model and not how they want to model.
When will CAD be so simple anyone can use it? Getting up to speed on a CAD system or pushing the limits has never been easier. This is an intuitive system that can infer what you're trying to accomplish. And it's a responsive system that makes your design experience feel immediate and alive. How many times have you had to prove someone else's work without the benefit of knowing how it was designed? Here an analyst finds a structurally deficient part as identified by the massive red areas. With synchronous technology, anyone can make complex modifications without needing to know how the model was created. Making the rib taller will strengthen the part. Throughout these changes, blends are maintained and key features such as the rib stay symmetric. Remember, the analyst had no idea of how the model was built, but could make the desired edits in a natural, productive manner. The associative connection to other applications is maintained, so parameters such as loads, restraints, and materials are remembered. A quick run of the FEA study shows an acceptable part. Synchronous technology allows you to take new approaches to the design and review of complex assemblies. This power transmission block is now in the review process. Review teams traditionally use visual techniques to interrogate the design. Traditionally, the review team would add some form of note or annotation and send it back to the design team to investigate a fix. With synchronous technology, the engineers on the review team can immediately begin investigating solutions using the sections generated during the review process. They perform what-if studies to see which change best solves the problem. Driving change through 2D geometry into the 3D model delivers power to edit models regardless of the way they were created, and you can immediately see the impact of the changes in the context of the total product, making design reviews live and proactive. No other technology gives expert designers or occasional users such design flexibility. Only with synchronous technology will all parts of the organization be experts.
So what does all this mean for manufacturers? Very simply, synchronous technology will connect everyone in the product lifecycle, occasional and expert users, designers, manufacturing engineers, and shop floor personnel, customers, and suppliers. And it will connect them without limiting any of them. Connection without limitation. Freedom with coordination. That's what we were striving for when we developed synchronous technology. How does it work? It's a patent-pending proprietary application built in conjunction with our D-cubed and Parasolid technologies, taking advantage of both of them. This layer simultaneously synchronizes the model geometry, behavior rules, and brings them all together with new decision logic into a single engine. The result is an optimal design solution that describes the model in a way that's flexible enough to accommodate even unplanned changes. Synchronous technology will be incorporated into the next releases of NX, Solid Edge, and of course the details of these product releases are rolling out in May. Their availability is scheduled for the summer, and of course that's right around the corner. Synchronous technology isn't just a vision, it isn't just a plan, it's not just a promise, it's here. And it's going to have a major impact on the products, the way they're developed, the way they're taken to market.
This is good news for manufacturers everywhere. And I hope today that we've given each of you a sense of why synchronous technology is great news for you. Simply put, you no longer have to choose between a constraint-driven or history-free modeling. You no longer have to be a programmer to reuse a CAD model. And you no longer need to worry about the difficulties of using data for multiple CAD systems. You wanted a breakthrough in digital product development. You asked us the tough questions, and we listened. Today, with synchronous technology, we're proud to say that Siemens PLM Software has delivered the answer.
Siemens.